Hello, dear CPL students, ATPL students. I hope you have been keeping pace with your ground training and doing the numericals which I have been putting up for you. And keep practicing them till you are able to do all of them correct. Today, we are going to do numericals on the shape of the earth, which we had started in lesson number 7, in which we studied the shape of the earth is an oblate spheroid, the polar diameter being less than the equatorial diameter. And we studied what is the change of latitude and longitude called dlat and dlong, difference in latitude and difference in longitude. Right. Today, we will cover the concept of what is an antipodal point, what is a north or south vortex, what are the different units for measurement of distance in aviation, and how to convert dlat and dlong into distance. Okay, let's start with the calculation of antipodal point. Antipodal point is a diametrically opposite point of any point on the surface of the earth. Which means if you start from that place, start digging through the earth, go through the center of the earth, and in a straight line come out at the other end of the earth, that place is called your diametrically opposite or an antipodal point. If your point is, let us say, 42 degrees north and 120 degrees 00 minutes west, for an antipodal point, as far as the latitude is concerned, just change the polarity. If it is north, make it south. If it is south, make it north. And to find out the longitude of your antipodal point, 180 minus your polarity, your longitude with polarity, in this case 120 west, your antipodal point will be 180 minus 120, that is 60 degrees 00 minutes. And don't forget, this was west, so this place will be east. And here, let's say one more for your practice now. Find antipodal point of of 37 degrees 30 minutes south and 28 degrees 40 minutes east. Apply the same logic. Latitude, change the polarity, longitude 180 minus your longitude, and also change the polarity, and you will get your answer. Right? Next, we will cover today what is a north and a south vortex. That is a track, a great circle track, that is crossing the equator, a great circle track, which is the northernmost latitude and longitude, and which will be the southernmost latitude and longitude known as north vortex and south vortex. Now see this track or the great circle. What is the track? If the track is 0, 5, 0, then the angle at which it cuts the equator will be 40 degrees, smaller angle, acute angle. If the track is, let us say, from here 330 degrees, then it will cut the equator at 60 degrees, smaller angle. Your north vortex will be this angle. In this case, 40 degrees north. And south vortex will be 40 degrees south. Here, 60 north and 60 south in this example. Okay. How to find out the longitude of the north and the south vortex? Find the meridian at which this great circle or the great circular track is cutting the equator, at which it is crossing the equator. Find the meridian. In this example, I have taken this point at 60 degrees east meridian. Then to the right will be your north vortex. To the left of this point will be the south vortex. Add 90 degrees to the right, 150 east. So this point will be 150 east. And antipodal point of this 30 west will be south vortex, or 60 degrees east minus 90 degrees will be 030 west, north and the south vortex. Like, okay. Would you like to do a practice numerical? I will give you some more later on. A separate lesson. I'll give you with all the number of numericals and the question bank. Here my question today is, find the north and south vortex of a standby, little bit. North and south vortex of a point, or rather of a track, and it's a great circle track, which crosses the equator at 45 degrees, 40 minutes west meridian, and the track is and the track is 295 degrees. This is for your practice. Okay. I hope by now you have noted it down. Then let me go to the next set of questions which we are going to do today. That is finding out the distance along a meridian. Let's say this is the meridian. Equator. These are the 2 points. Since meridians are great circles, 1 nautical mile is 1 minute arc of a great circle on the earth. So here, dlat in minutes between A and B will give you the distance in nautical miles. But both these, there should be no dlong, only dlat. That means these two places are on the same meridians, and meridians are great circle, and 1 minute of a great circle is 1 nautical mile. Okay. Just a second. Can we convert dlong also into distance? Here in this question, A to B on the same meridian, C to D again on the same meridian. Find out the difference in latitude and you will get the distance in nautical miles. And how to convert dlong into minutes, rather nautical miles. Now let's take these places A and B. They are both on equator. A is 10 degrees west, B is 10 degrees east. So dlong will be 20 degrees east. And converted into minutes, it will be 1200 minutes. At equator, since equator is a great circle, change of longitude in minutes, dlong in minutes, will give you the distance in nautical miles at equator. East-west distance in navigation is also called departure. Departure is distance measured east-west. That means on the same parallel of latitude. Now between C and D, E and F, the dlong is still 20 degrees. Because this meridian is 10 west and this second meridian is 10 east. That makes it 20 degrees. But as we go towards the pole, since these meridians are converging, the distance keeps on reducing, and at pole, the distance becomes 0. So we can say at pole, the distance between these 2 points becomes 0. What is the formula applicable for all latitudes? At any given latitude phi, called phi is the latitude, find out dlong in minutes, let's say between C and D. Dlong in minutes multiplied by cosine of that latitude. Now here my dlong in minutes was 1200. But if the latitude is 60 degrees, into cosine 60, which will be 0.5. So the distance will be 600 nautical miles. Similarly, you can try between E and F. If the parallel of latitude is 75 degrees, in this case north. So even if the latitudes are south, the formula remains same. As you go towards South Pole, distance east-west keeps on decreasing, and these are the meridians converging towards north and the south poles. Fine. Little bit of practice you would like to do 1 or 2 today so that you can now cover these numericals from your other question banks also. One for your practice. Place A is 40 degrees north, 15 degrees 20 minutes east. Place B is again 40 degrees north, 72 degrees 30 minutes west. Find the distance in nautical miles between these two places. And what will be the track? One place is east, other place is west. Parallels of latitude lie along east and west. Equator lies along east and west. So in this case, you're going from place A to B. So your track will be 270 true. You can even find out the track. Similarly, in dlat dlong, your track will be either north, and if your dlong is south, second place is towards south of this place A, even if they are both in the same hemisphere, a second place is south of place A, then your track will be 180 and this track will be 360. So you can find out track and distance between the places if they are located on the same latitude or same meridian or the parallel of latitude. Okay, now we have been talking about nautical mile. What is a nautical mile? There are 3 units of distance measurement in aviation. That is statute mile, nautical mile, and kilometer. Statute mile was fixed by a statute or law. It's 5280 feet is the length. If we take feet as the common denominator. Nautical mile is related to the shape of the earth or a great circle. Like you see, this is starting from here. Either you go this side or from this side you are traveling on a great circle. Each 1 minute of a great circle will be called 1 nautical mile. And or you can take from the center, take this arc of 1 minute at the center of the earth, 1 minute. Here, center of the earth, 1 minute of arc. Then this distance arc at the surface of the earth will be 1 nautical mile. And since earth is not a perfect square, this 1 nautical mile distance near the pole will be greater than the distance near the equator. And that is called geocentric nautical mile. For our day-to-day use, we take Earth as a perfect sphere with only one center. And the average length of 1 minute of a great circle or 1 minute at the center of the earth is called 1 nautical mile, and its distance is 6080 feet. And we call it an average length, 6080 feet. Kilometer is a distance measurement in the metric system, is 1 by 10,000 of average distance from pole to equator. Here again 10,000. 10,000 kilometers, this total distance. This total distance will be 10,000 kilometers. Again, 10,000 plus 10,000. So total circumference of the Earth is 40,000 kilometers. In nautical miles, it will be 360 degrees of a great circle. Each degree has got 60 minutes and the distance will be 21,600 nautical miles. Circumference of the Earth, 40,000 kilometers or 21,600 nautical mile. The average length of a kilometer is 3,280 feet. For your quick mental calculations, although you can do it on nav calculator also, 1 nautical mile is equal to 1.852 kilometers, which is equal to 1852 meters. That is the ICAO definition, 1852 meters. And 1 kilometer, as you know, has got 1,000 meters. A nautical mile has 6,080 feet. Each foot or feet has got 12 inches. And 2.54 centimeters will be equal to 1 inch of distance. Some of these formulas should remember by heart. Every time you don't have to run for the calculators. And we will be doing these questions in our maps and charts. I repeat, 1 nautical mile, 6,080 feet is equal to 1.852 kilometers or 1852 meters. Each meter is then 3.280 feet. Each meter is 3.280 feet or roughly 3.3 feet. Each 1 foot has got 12 inches. Each inch is equal to 2.54 centimeters. I'll suggest remember some of these things by heart, and that will save your time in your question paper. Otherwise, you'll be every time looking for a calculator to calculate this conversion. In maps and charts, there are many questions in which maps and charts lessons on questions on scale. There are many times you will need this information with you. Why? As I've been always suggesting, whatever I teach you, don't forget to convert it into your register. Now here it may say jumbled up, but as I was explaining it to you, I have written left and right. You convert it or put it back into your register. See this video twice, thrice if you like to. And if you have a friend and you are doing it together, then sit down together, do this, then give each other questions and answer. And I will be giving you a question bank. Sooner than later. Questions on what we have studied in dlat, dlong, how to convert distance, dlat and dlong into distance. What are the units of distance? Okay. And till then, you can practice yourself so that the day I put up a question bank for you, you can solve it as soon as possible without making mistakes. And like I've done in the past, I will also be giving you the answers. I think that is where I'll stop today, although we are not yet done with the shape of the Earth and the other definitions connected with it. Soon we'll be reading a relationship between the great circle and the rhumb line, and what is a rhumb line, and what are the angles between these two. That save it for the lessons to come. Today, be satisfied with what you have covered. And don't forget to practice the questions related to this. And if you're liking my videos, do share it with your friends and your other colleagues, your batchmates in your flying club. And subscribe to my channel and keep with me. And I'll do my best as good I can do for your success. Good luck, all the best, happy landings, and we can stop here for today.